So if you lower the car by 20 millimeters, you have like 50, 60 plus millimeters, depending on your axle, where your roll center is going down. So even if your center of gravity is lower, your lever arm between an imaginary rolling axle and the center of gravity became bigger. So you have a good chance of rolling more than before.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Thomas from KW Suspension in Germany. No big surprise here, but the suspension system in your car plays a pivotal role on not only the comfort but also the performance of that car. The old story is that irrespective of what car you're driving and how much money has been spent on all of the elements of that car, ultimately it really comes down to that contact patch between the four tyres and the racetrack, and that's going to define how quickly you're going to be able to get around a lap. And of course, the suspension therefore plays a massive role in controlling and maintaining that contact patch. So in this episode, we jump into some of the more technical terms behind your suspension system. Two of the key questions we always get, which I've tried to answer within this podcast episode, are what spring rate should I run and how should I adjust my bump and rebound dampening? And we dive into those topics in detail, among others. Before we get into our chat with Thomas, for those who are maybe fresh to the HPA Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune engines, how to build performance engines, how to plan and construct reliable wiring harnesses. We also cover race car setup and race driver education topics using our range of video-based online training courses. This gives you the benefit of being able to learn from the comfort of your own place, and you can also learn at your own pace. Once you purchase any course from us, it is yours for life. It never expires. Rewatch it as many times as you like. You can find a full list of all of our courses at hpacademy.com/courses. And as an added bonus, as a podcast listener, you can use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put links to the coupon code as well as our courses page in the show notes to make it easy for you to find. All right, enough of that introduction. Let's get into our chat with Thomas now. All right, Thomas, welcome to the podcast and thanks for joining us. As usual, let's start with a little bit of your background and we'll want to learn how you got interested in cars in the first place.
Okay, thanks a lot. It's a great pleasure to talk here. Actually, it was for me pretty easy to get involved into racing because I'm grown up in the Rhineland area, 50 kilometers away from the Nurburgring. And I went there quite often with my dad to DTM or to Formula One. Basically, we could never afford to go racing or something like that, so we were watching it. Over the years, it became more and more to my mind to be a part of racing and working in it, first as a mechanic and then as an engineer. Basically, that all started with an internship after school in Europe, pretty famous team Zakspeed. They were running Formula One in the 80s, and I started there an internship 20 years ago, and that's when it started all over, basically.
Okay, so a bunch of stuff to go back and unpack there. Certainly, I could think of worse places for a motorsport fanatic to grow up than 50 kilometres from the Nurburgring. So, yeah, very fortunate, I imagine, there. In terms of that internship, prior to starting that internship, had you built up any skills off your own back of working on cars in terms of, did you have a mechanical skill set already, or were you going into that internship relatively fresh with no real developed skill set?
Basically, over the years at home, I run a screwdriver all the times that I could. That I was a rather radio-controlled car or a bike or motor-driven bicycle or something like that. But it was always, although clear that I'm a theoretical head, I was drawing a lot of things, and so my parents told me, okay, your biggest capital basically is your head. You need to use it. So I run school until the end. And then I've seen in the local newspaper written that Team Zakspeed was looking for internship people, and I just wrote an application and I got hired. And just by that time, the idea came up to study mechanical engineering or automotive engineering.
Okay. So how did the mechanical engineering sort of work alongside this internship? Are you doing essentially two things simultaneously, some formal qualification study as well as learning hands-on the job as an intern?
Basically, that wasn't connected by the company or the university. I was just studying, say, all the holidays I had and all the weekends I could take off. I was then part on the racetrack or being part in the workshop, and I remember myself going by the night train to Budapest, the Formula One circuit, and studying in the train, and in the morning packing my bag and heading off to the racetrack there. And there were some quite exciting years to do that till studying was finished. Yeah, I mean, whilst studying, I couldn't afford a car or something like that, so I went to the racetracks by train as long as I could, and then we started all over. Yeah.
So you're basically living your motorsport dreams vicariously through these other race cars on track.
Yeah, that's basically what it was. And I was the tire guy, so I learned everything about tire pressure and how to adjust it correctly. And I did that later on in FIA GT1 championship. So that was already a really professional surrounding, and to know how to adjust the tire pressure on Michelin competitive tires correctly, and then being a mechanic. And in the last second year of the university, I got a laptop into my hand, and the first engineer told me, okay, now you're being a data engineer.
Straight in the deep end.
Exactly. And you were just doing it, and yeah, try to get over the things and working with the driver and working more and more technical. Yeah.
Okay. A couple of things I just want to dive back into here, and this is probably a little off our specific topic today of suspension, but because you raise it, I just wanted to dig in a little bit. You mentioned tire pressure, and for me, I think this is probably one of those areas that offers essentially the potential for almost free performance. You know, it costs you nothing to adjust and set your tire pressures correctly. Yet time and time again, I see it as one of those overlooked areas of motorsport. So I know that it is a reasonably deep topic if we dive right into it. So let's just cover a couple of the key elements. So I guess one of the common questions that come up at a motorsport level is, what tire pressures should I be targeting? And what I'm talking about here is hot running tire pressures. So again, like, this is not a black and white answer. The numbers from one car can't necessarily be applied to another. What I'm looking for is, can you give us a little bit of an understanding of how we should be deciding on the correct hot running tire pressure for a given tire, a given application, a given car?
Yeah, basically, let's say on a race car, even on a club sport race car up to GT race cars, you should not overshoot 2 bars or 2.1 bars, something like that warm. Let's say that's pretty rough. Back in GT1 championship, we were driving 1.6 bar, 1.5 bar warm. So starting to before putting the tires into the blanket, even with 0.9 bars, that was pretty extreme back in those days. Now the tire manufacturer is always giving you an advice: don't go under 2 bars, but you can have a look on the surface of the tire, and you measure the temperature, the surface temperature, on 3 points: outside, inside, and middle, and you see how your temperature is developing. And from then on, you can have a good view on what you are actually doing.
I'm just interested in terms of using tire pyros like that, measuring across the tread. So, I mean, there's two elements that we can pick up from that. One is the tire pressure, and the tendency here is that if the center temperature is higher than the inside and outside, it means we're overpressured, and essentially the tire's almost taken on a slight balloon shape and is contacting the track primarily in the center. underinflation would show a lower temperature in the center. So, I mean, that's a guide. It'll also give us an indication of whether our camber settings are optimal. The downside I see with this is that we obviously aren't measuring those temperatures live, and there's a technology to do so, which I'll come to in a moment, where we're measuring them mechanically back in the pit. So depending how the car is being driven after it's come off the last corner, how long the straightaway is into the pit entry, how long the pit entry is, all of those things will actually affect the temperature that we measure when the car comes to a stop. How relevant, therefore, is that information? Is it compromised compared to the alternative of measuring in real time using infrared sensors on the car?
For sure. I mean, if you're testing somewhere alone on an extreme racetrack that can, under extreme conditions, for example, on the Nordschleife, we just been to NLS1. It is so cold outside, and you have the long straightaway Dörtinger Höhe, and if you measure it then into the pits, you maybe get a wrong picture. So for sure, you have to see all that surroundings and just make sure that you are in the right window. And for sure, the wear of the tire in that moment is also giving you an indication. So it's still, after 20 years, the first thing, if somebody is coming to me with a suspension problem or something, the car is coming in and please turn the steering wheel and let's have a look on the tire and show me your tire data. And from then on, we can talk. That's pretty much a basic thing.
And I think it's very easy to lose track of course, the modern race car is a very complex piece of equipment, and you can't really look at one system, such as the suspension, as you mentioned there, just purely in isolation. And it's a case of understanding the interaction of all of the components and then looking at the entire system, at least I believe, to try and sort of zero in on where a particular problem lies. And it's essentially just making sure that the baseline is correct and you're within the operating window for things like tyre pressure, camber, for example, before you start trying to fix an inherent handling issue, potentially with suspension. And then you find out that actually maybe the issue is just purely that you're way underinflated or way overinflated with tyre pressures. Now, the other element before we move on from tyre pressure is cold starting pressures versus hot running pressures. So really what we're trying to do is choose a cold starting temperature. And I say cold, it's a relative term. Either we're using maybe a tyre blanket, or alternatively they're going into an oven to preheat them before they go on the car. But really, that's what we're trying to do, is choose what the cold starting pressure should be in order to target what we want hot running. And I mean, again, there's a lot of elements that go into this in terms of, you know, the type of car, how aggressive the driver is, the track, etc. You know, what sort of range of increase in tire pressure do you see from when the tires go into the oven to when they come off the car at the desired target pressure?
I'm pretty much not viewing that nowadays anymore. But when I remember also my days as a race engineer, you basically run in first free practice a little bit of a cold pressure where you think, okay, that's maybe a little bit too much. Then dropping the tire pressure warm to 2 bars, for example, both axles, and then put it into the corner where you have almost 20 degrees, or you track a certain temperature and then measure your cold pressure from then on. Because then you also have all the symmetrical or unsymmetrical effects from the track already within your cold pressure. And if you stick to that over the weekend, you can't be so wrong, except for you're running in a GT3 team on the Nordschleife, for example, or in DTM, where you have the full view over the data. I mean, if you're running a GT4 car or a TCR car where you don't have all the valid data which are giving you the answers.
I assume on those higher class cars, if you're running telemetry and have a TPMS system on the car, I mean, from the race engineer, you're getting that data live in real time, so you instantly know if you got your cold starting pressures correct, and then you can adjust. You mentioned the asymmetric effect there. So I mean, again, for the uninitiated, you might think that we set all 4 tires to the same cold starting pressure. The reality is that for a predominantly anti-clockwise circuit, for example, we're going to work the tires on the right hand side of the car harder than the left. So we may start with those pressures a little bit below the pressures for the left. So it is a complex element. And again, I don't want to dwell on it too much. One last element I will mention though, I referred to it briefly, infrared tyre temperature sensors mounted on the car giving real-time feedback. How much of a game changer is that, seeing what the tread temperature is doing across the width of the tyre tread real time in a corner when it's hard loaded up versus measuring in the pits with tyre pyrometers just when the car comes back in?
Yeah, basically my last internship or the last station within studying was at Volkswagen Motorsport. I wrote my final diploma work about third element damper in a Formula 3 car. And there we were having also a huge look on tire temperature, measuring pressures and all that kind of stuff in a work surrounding. And we were comparing for the first time, let's say, our measurements that we took roughly when the car was in front of the pits, comparing it with what was going on the track. And you can drive in the complete wrong direction if you don't do it promptly. And if you wait a minute or 30 seconds, that's why the guys are jumping onto the tire as soon as the car is standing. And for sure, also how the outlap was looking like or the track was looking like, that influences that thing massively. For sure, you need to get the basics right, and you need to know what you're doing.
Yeah, I do think it's an understanding of the principles and the process, and particularly if you want to get useful data from a handheld tyre pyrometer. My advice here is you don't want to be doing a cool down lap and then rolling into pit lane. The car has to be driven hard right up to the pit entrance, and then immediately the car's stationary. You need an extra person to be going around and gathering that data immediately that the car's become stationary. Otherwise, as you say, I mean, even 30 seconds waiting, the tyre temperatures will start to equalize across the tread. And again, if you're doing a full cool down lap, basically, at least in my opinion, the data is probably close to garbage. Let's move on though. As I said, this is a little bit of a divergence just because I think that's an interesting topic that kind of parallels our chat today on suspension. Let's move on from your internship. So you mentioned just before we got into this tyre pressure data analysis. And I mean, that's another key element of getting the most out of the car, and the driver for that matter. Was there any sort of formal training that you got with data analysis, or was it a case of here's a data analysis package, figure it out?
Yeah, exactly. Basically, it was a pretty cold start. When I worked today together with young engineers, they are always asking me, how am I going to learn it and things like that. And I said, okay, there are a lot of race car engineering magazines. Go through it and start to work on the car, and sooner or later you will learn it and you will figure it out. I mean, I got some good engineers around me, which had also Formula One or Group C experience from back in the days, showing me some things. But basically, all the data engineering programs like Bosch, Windarab, you have to go through it. You have to work with it. You need to analyze all the sensors. And the more you do it, the closer you will come to what is effectively important on a testing session or on a race weekend. Basically, there was no training or training structure within that days. But that's 20 years ago. Probably today that's totally different.
Yeah, probably a good point there. 20 years, there's a big generation change in terms of the technology, the sensors, the systems, etc., and of course more training available for them. I mean, obviously you're operating here at a professional level, and there's going to be discrepancies between the systems and the sensors that you want to see at that level versus, sort of entry level, club level racing enthusiasts just getting started. Could you give us, again, a little off topic, but just while we're talking about it, could you give us your idea of what the key sensors are that someone just getting started with data analysis should be focusing on, so that they're not overwhelmed by a million different channels that may not be immediately relevant to them? Basically, what is the low-hanging fruit, in your opinion, of a data analysis system?
Yeah, that's absolutely a good question. We got that question quite often. I think the most important thing, firstly, are the wheel speeds. Because, I mean, almost every club sport race car or TCR or GT4 has acceleration sensor, at least in the middle of the car. You have your speed, you have your steering angle and your revs. And on top of it, if it comes closer than to suspension, you have your wheel speeds. Because if you don't have a four-wheel driven car, you can compare already a lot. I mean, you can compare already, are your wheel speeds overshooting somehow during braking? I mean, theoretically, if you're coming from a mechanical engineering study or something like that, that overshooting in braking zones is kind of important to build up forces. Accelerating out of a corner, you have the difference on the driven axle left to right. If it's a rear driven axle or a front driven axle, doesn't matter. You have your axle which is not driven, and you have your difference in cornering, and you can compare that difference with the difference on the driven axle. So already, I mean, that is giving you a lot compared to steering angle and accelerations. And this is also what I tell young engineers. Before you making the big suggestions and coming up with all the mathematics you have learned, just learn how to run with those 5 sensors.
Yeah, I think it really is a case of less is more. And I mean, as a bit of a data nerd myself, there's always that temptation to add more and more sensors. And the reality is that, first of all, it's going to take more time to analyze all those additional channels. Probably more importantly, if you don't know what you're looking at, essentially the data is going to be useless to you. But I mean, everything we do when we're trying to improve the lap time of a car, and this comes down to driving technique as well as chassis balance, is all about improving the speed, making the car faster. So the wheel speed channels, those are going to tell you whether you're going in the right direction. So yeah, absolutely. I mean, of course, there's a bunch of other channels we can then start adding, but I think getting those fundamentals dialed in and understanding what you're looking at and understanding how to quickly analyze them, that's really the key. Right, let's fast forward a little bit. So beyond this internship, let's catch us up with the point where you got involved with KW Suspension. How did that sort of pan out for you?
I was, next to my job at Volkswagen in Wolfsburg, I was self-employed with a racing company, and I was race engineer just on the weekend. I was involved in 24 hours race. We had a race there with a TCR car. That was back in 2016. And I was leading that team basically. We had 3 cars and 30 people already. And one of the CEOs from KW was one of the drivers. And he basically was asking me if I want to run the racing department in his company. And I wasn't so sure from the beginning on, because KW was always known for street and tuning suspension, and I had not a lot of let's say experiences with them on race cars. I mean, back in the early 2010s, Öhlins was coming up quite massively. ZF was becoming a little bit weaker, and there were some changes in the market, but KW wasn't that dominant to me. And then I had to think for, let's say, 1 or 2 years, and then I got invited to Fichtenberg, which is a really, really small town within the Swabian Mountains. Pretty much, if you coming from Sydney or from big cities all over the world, you would not think that a technology company like this is sitting there in the forest. Yeah, and I was living in Hanover on that point, and driving down there and leaving the autobahn, and basically I was driving through forests and little streets, and I think I got the wrong way. For sure I got the wrong way. And all of a sudden KW was coming up, and the company was shown to me, and the products where they want to head to. But the most important thing were the people and the engineers working there. I realized from the first moment on, okay, they don't wanna stand still. They wanna enter the motorsport market. I totally can imagine to be part of that.
Well, let's get a bit of an overview then of the sort of operation that is KW Suspension here and now in 2023. So can you give us an idea of the size? Is it just the one location, or are there multiple locations? how many staff, etc.? Let's get started there.
Basically, we have 380 people working on the headquarter in Fichtenberg. The whole group worldwide is employing 1,200 people, I think. We got BBS now in the group. We got Riga Rally Suspension in the Netherlands in the group. The US place is covering 70 or 80 people within California. And we have little occasions which are completely KW within Singapore and Japan and in Asia. And I think in Australia is also something starting now. So
you're kind of a big deal. That's a big operation.
I think so, yeah. I mean, when we compare us to Bilstein or ZF, the even big suspension companies, we are still small, but within that niche where we are basically becoming bigger and bigger.
Sure. Okay, I'm interested if you could maybe give us a bit of a breakdown of, in terms of sort of sales or focus on products, what percentage of KW is focused on modified road car suspension versus pure 100% motorsport application?
I would still assume that probably 85 or 90% is still aftermarket applications, and 10 to 15% of the turnover is being motorsport plus OE business on the street and OE business in motorsport.
Okay. We're going to dive deeper into what sort of separates a motorsport damper from a road car one as we go through this. But I'm just interested, is there any sort of filtered down effect in terms of what you learn and develop in the higher echelons of motorsport? Does that sort of filter down and get applied into road car suspension, or is it really sort of a given that the suspension is what it is and the two can be considered entirely separately?
Yeah, no, I think on that day where everybody is thinking it is what it is, that's the point where you're about to fall back. That's what I strongly believe. I mean, if you look in automotive industry, there is almost no innovation from a race car within the last 100 years, which isn't relevant for street nowadays in some point, even if it's a little bit different. So our variant 3 suspension system on the street is a former race damper. It was a race damper principle within the mid 80s, and we still use it in racing, in basic club sport racing, but it started as a race suspension. And the compromise from the hydraulic back in the days was just generating more grip. And what is generating more grip on the racetrack is generating more comfort on the street. Simple as it sounds. It is like this.
I'm also interested, just you mentioned that Riga rally suspension that's under the umbrella now of KW, which is something I didn't realise. I sort of got a brief background in rallying here in New Zealand when I first got my start in business and was tuning quite a few rally cars. So I've sort of got a little bit of experience there, definitely not too deep. But rally suspension in particular, it runs in some brutal conditions, and we do see there's a massive difference in price point and functionality between some of the more entry-level rally car suspension and the top of the line, such as Riga. Is there anything that KW sort of could learn from Riga when that came under the umbrella, or again was the development already there and KW didn't really take too much from that purchase?
No, we basically started to work together pretty close. There will come an off-road suspension also for aftermarket suspension level on different markets where you don't sell variant 3 because it's simply not relevant. And that technology is effectively coming from Riga in their dampers. And basically, we are looking quite a lot what they are doing on rebound stops or hydraulic stops, because that is very interesting for us to derivate that also for the racetrack and for the street. Also material strengths, there are quite some things to learn, definitely.
Okay. On face value, you'd sort of say that suspension for an automotive application is a fairly mature industry now. And obviously, I'm not deep in this, but from face value, you'd sort of think that there's not a lot of innovation still going on. Is that true? Is it sort of minor refinements and iterations, or is there still the potential for some relatively significant breakthroughs that are going to transform the functionality and usability of a coilover or damper or whatever you've got in your car?
Basically, during my working life, I also could take a closer look on what is going on in street development. Basically, their toolbox is a little bit smaller because you are not allowed to use so many parts or to use so expensive parts in your hydraulic toolbox, but they are deeper into it. They use it more into deep, and they are obviously a lot more cost driven. And I think they still do a massive, innovative, and good job for that cost level where they're in it. And basically, when I see now electrical cars are becoming very big in Europe, they're a lot heavier, and they still have to manage to build dampers with that small toolbox for cars which have bigger wheels now and are heavier. But for sure, little companies like we are or like Öhlins was back in the days, they can think of more innovative and not thinking so much into processes. So I think effectively you need both. And effectively you can run only and think only in processes or only think in innovation. It has to come together on one point, and then you can put your innovation into the big series. I think there's still a lot going on, and I think it's still everybody is still working on it.
All right. Let's dive back into your specific role at KW. I mean, clearly you're focused and involved in the motorsport side of things, but yeah, could you sort of give us an idea of what your day-to-day looks like and what you're actually doing within KW?
Basically, I'm leading within my department now 26 people. We have mechanics, we have a sales team, we have an engineering team, and all that sort of stuff. And basically, as a general manager in that story, you're actually organizing and planning a lot. Basically, later on in the evening or when the working day is being closed, then you can take a closer look into technology. I think, yeah, I think you definitely have to organize a lot and enable the people that they can work. That's to me the biggest task you have as a general manager. Just see that the people are able to do their job, and you should be the motor for innovations and drive that and talk to the customers and see that you simply don't stop. Because even if a race car today, like a GT3 car, is homologated for 5 years, and you send out hundreds of dampers, which are pretty much the same for the same car, you still need to take care of that you're innovative and that the manufacturers and teams don't put you into question. Because that happens so easy, and one day you don't realize. And that's probably the day where your story of building race dampers for a particular manufacturer is stopping.
Yeah, okay. Now, again, without me really knowing the full capabilities here of how this all works, what happens? Does an OE manufacturer of a GT3 car or a TCR come to KW and say, hey, look, we're developing this new platform. We want to partner with you to design and develop the suspension package? Or is it individual team owners that are coming to you to improve the suspension on their existing race car?
Basically, we had to do a lot active sales like 5 years ago when we were doing some project with Porsche, but also having some problems on particular race cars. We work together a lot with the manufacturers. The manufacturers are also coming and asking us, can you offer us for that GT4 or that GT3 project a suspension kit, and what would you suggest? That's one part of the story. The next part of the story is, as soon as teams or let's say close teams to manufacturers are getting the cars, they're asking you, okay, we have that and that problem. How can you help us on that? Is there anything what you can do for us? And on top of it, you have the whole individual customers. You still have that on the Nordschleife. You still have, let's say, a class on the 24 hours of Nurburgring where cars are really, really close to production cars, and you manufacture your suspension kit purely for them. You have basically all of it. And I think the other damper manufacturers don't have that variety, probably. I think, without telling any names, I think none of them is like really only is basically only Formula One and LMP, and the rest they don't care, and the other ones are only on basic club sport cars. I think we look into everything now.
Yeah. All right, let's just dive into the function of a damper and a spring. And I mean, again, these are relatively complex devices, but is it possible for you to give us maybe a high-level overview of how the spring works and how the damper works? And I know this is a little tricky as well without the ability to have nice, simple drawings to go along with it. But if you can do your best.
Okay, so basically the spring, let's call it a stupid piece of part. Yeah, it's just storing energy and giving that energy fully back. And you just need to have the spring in the car to keep a certain height or to keep a certain body control. And the damper is basically doing everything around it. It's controlling your pitch velocity, your roll velocity. It's absorbing all the energy which is coming into rebound direction, absorbing a lot of energy which is coming into bump direction. And then you have to have a look how your energy is, let's say, how you work on your energy, what the spring is producing. I mean, you have very expensive damper system. The spring is compared to an air spring system. A steel spring is pretty much in everything kind of the same. You can have it progressive or linear, but what is very important is the spring actually is giving you the performance. The car isn't performing better just because of a damper. It's performing better to use the spring as it is, to keep it as soft as possible and as hard as necessary. And the damper is only the workaround for that fact. That's basically what I think.
The way I sort of like to think of this as well is if we consider the two in isolation. So we have a real basic model of a car and all we have is springs with no dampers. And that car then negotiates a bump. So the spring, as you mentioned, is a necessary element there to maintain contact patch with the road, etc. But as we negotiate that bump, then the spring is constantly essentially oscillating. So we have no control. The car will just start bouncing and essentially within reason never stop. So we've got the damper in there to do, as its name would suggest, to dampen out those oscillations and get control so that we don't continue to bounce. So the two are very different elements that it can't be considered in isolation. It's all about controlling that contact patch with the ground and controlling the energy, as you mentioned, stored in the spring. Now, if we can get into some of the elements that I often hear, so the biggest question we always hear when it comes to suspension is, what spring rate should I run? That's an easy question to ask, but a little bit more complex to answer. And I mean, I'll preface this with, there is, sadly, for those who are waiting for the magic answer here, there is no black and white answer to what spring rate we should run. And it really goes a little deeper than that anyway. So can we go back to sort of natural frequency of the suspension system and consider how we'd choose a suitable frequency based on application, and then how that sort of filters back to what we need to choose for a spring rate? And I know this is reasonably complex, but can you take us through it, please?
Yes, no problem. Back in the days, I was also working at Volkswagen Motorsport when the Polo WRC got developed. And let's say our first suggestion back in the development was 1.1 1.15 hertz on the gravel kit. let's say. So all around 1 hertz or a little bit above it. That was our suggestion. For asphalt, we were aiming like 1.8. Later on, Formula 3 was about 2.5 to 3. GT4 car is roughly 2.5. GT3 car is roughly 3.5. And when it comes to high aero downforce cars like LMDH or something like that, we pretty quick talk about 4 hertz or even above.
Okay, I'll stop you there before we sort of go deeper. For those who are currently starting to glaze over and have no idea what you're talking about with this 1.5 hertz, 3 hertz, what is that reference to?
That is referring to the spring rate and to the weight what you have on the corner, plus the ratio between damper and wheel. That's basically what it is. It's always taking into account that you try to level a certain mass of the car and a certain spring rate together.
Okay, so basically we're choosing that frequency based on the application and the type of surface we're going to be running on. Obviously, a road course versus rally on dirt/gravel, dramatically different. Obviously, the gravel is going to be far bumpier than asphalt. So that's one consideration. So we choose sort of a natural frequency based on that application, and then to convert that natural frequency into an actual desired spring rate, that's where we take into account the mass of the components, as well as I call it motion ratio. So essentially where the damper is located in the suspension system. So if we look at McPherson's strut, we're reasonably close to a 1-to-1 ratio, by which I mean if the wheel moves up by 10 millimeters, we're going to find that the damper is going to move pretty close to 10 millimeters. And for those being super fussy, yes, I know it's not a specific 1-to-1 relationship, but it's very close. Then you look at multi-link or double wishbone suspension, and ultimately, depending on where the damper is connected to the arms, we might be looking at a 0.5 motion ratio, where for every 10 millimeters the wheel moves up and down, the damper is actually only moving 0.5. So that then drives the requirement for the spring rate, correct?
Mm-hmm. Exactly, yeah.
And that's why, as well, for those who are sort of have looked at spring rates, the sort of spring rate you'll see on a typical road-going car that's doing track days for a McPherson strut is going to be dramatically different to a multi-link where there's that massive difference in the motion ratio. So that's one of the reasons why we can't sort of say, oh, well, this car here, which is completely different to my specific type of car, this is running a 500-pound spring, so obviously that's what I'm going to run. It doesn't work that way, does it?
Yeah, exactly. I mean, that whole frequency story is always taking into account that your geometry, basically your whole suspension geometry, is healthy, as well as the anti-roll bars. I mean, I've got that question also very often, that soft spring has to work. We need to run that soft, and you see that they are always running on the bump stop. And later on, you realize the anti-roll bar is way too weak. For example, that's also affecting it. Or a roll center just was diving down into the ground because the car is way too low. You need to take that part technology-wise also into account.
We'll talk about roll center height as well, because I think that's a really key element that is so easy to overlook. But I mean, essentially taking away from what you've just mentioned there, and I wholeheartedly agree, we can't look at one element of the suspension in isolation. We need to understand the suspension as a complete package. So that's really important. Just coming back to these spring rates though, so you've gone through this calculation from your desired natural frequency and you've come to a spring rate for that particular application. Now, even at this point, at least as I understand it, this isn't sort of now set in stone. There's still, it'll get you, I guess, how would we put it, maybe in an operational window, but within that window, we may still desire to go maybe a little bit softer, maybe a little bit harder to suit a specific track condition, or maybe even a driver preference.
Yeah, I mean, yes, you basically explained that right, that you always have a certain window where you are in, and it also depends on what kind of quality damper system are having the car running on. I mean, if you have a damper which is very, very simple single tube, only a huge gas reservoir of 40 bars, and then you have to run a hard spring because you cannot work on the hydraulic so much. If you have a solid piston damper where you have all the hydraulic support, for sure you can go softer and end up on a lower frequency level.
Let's just dive into that a little bit, because this is sort of starting to walk along the lines of the limits of my understanding. And if I'm starting to sort of fall off here a little bit, I have no doubt that some of our listeners are. So the single tube versus solid piston, I think, were the two terms you used there. How does that influence the capability of the damper, and why does that then drive what spring rate you're capable of running in terms of softer versus harder?
Because, for example, the single tube damper where you only have a gas reservoir, you need to run inner oil pressures in the damper, which are pretty high, to generate forces. For example, just to throw a number into the room, when you want to generate, let's say, 3 kilonewtons of force at a half meter per second, you need to run with the single tube damper like 220 bars. Inner pressure. The solid piston damper can reach that amount of force with a lot lower pressure, like 50 or 60 bars, something like that. And therefore, you can reach that force level easier and more on point, and you then have the better damping, lower contact patch load. You're not moving so much, and therefore you can go on a softer spring to lean more on the hydraulic with the car.
Okay. So really this just comes down to a fundamental difference between the design of the damper, which I can only imagine then drives the price point of the damper. So if I'm picking up what you're putting down here, essentially these are some of the core differences between a lower price point product and the more expensive motorsport specific products. Is that sort of a rough guide on what you're talking about?
Yeah, exactly. And our mission is also to have that technology which we are driving in the race cars to enable also the street department to offer that for the street cars.
Sure.
Because I've no idea how famous Manthey Racing is down there in New Zealand, but they are offering packages for Porsche street cars where four-way adjustable dampers are ending up in the street cars street legal, and they are more comfortable than their normal OE suspension.
More comfortable, yet also superior.
Yeah, exactly. I mean, more comfortable, generating more grip, just because the inner pressures of the damper and that whole harshness story within the whole suspension is not that sharp anymore.
I think this sort of comes back to another conversation, which again, for the uninitiated, if we've just driven a modified road car and then we see race cars and how low they sit on the racetrack, there's this expectation, I think, that stiffer in terms of a spring rate is better and makes for a race car. And basically what I'm hearing you say here is it's actually the polar opposite. Well, obviously within reason. And if you've got the ability for the damper to control the spring, you can actually get an improvement in contact patch by going softer. Again, am I picking up what you're putting down correctly here?
Yeah, basically that's right. Although under the circumstance that you have enough travel left until you reach your compression end. I mean, the soft spring doesn't help you if you run on bump stops and packers all the time. So you need to be geometrically healthy and anti-roll bar wise, you need to be healthy. But then the soft spring is definitely helping you.
Yeah, and I mean, again, that just reiterates the fact that we do need to consider the suspension system in its entirety. So it's not just this one element of, okay, well, let's go softer with the springs. Completely agree with you. Obviously, as you go softer for a given amount of load in a corner under braking or whatever, the suspension is going to compress further. So you're more likely to end up on the bump stops. What I'm interested in here And also, I suppose we should mention that in some instances, running onto the bump stops is actually not necessarily a bad thing. We might elaborate that on in a moment. But the element that I'm interested in here as well is, as we go softer with the suspension, we tend to find that the car will, for want of a better term, move around more on the track. And what I mean by this is, if we're, again, just considering a change in spring rate, going from a hard, stiff spring to something softer, in a corner, the car's going to body roll more, it's going to dive more under braking, and it's going to squat more under acceleration. So all other things being equal. Now, is that necessarily a bad thing? Are there other elements we then need to do in terms of our damping to help control that? I mean, my understanding is, if we're looking at our damping, it's not ultimately in a corner going to affect, once the car is settled in steady state cornering, it's not going to affect the body roll or the angle. What it can do, however, is affect the roll rate, so how quickly it'll take that set to its sort of steady state condition. Again, if I got that right, and if so, what considerations are there around that side of a softer spring?
Exactly. You basically, in all that transient situation, you unload the tire a lot less if you have the softer suspension. Plus, you need to have a look on your contact patch load variation. That variation is being lower. You have more contact to the road, but you still need to have the full surface of the tire on the ground. It doesn't help you if you watch rally cars on normal racetracks. You always see that the tires are off camber completely. That won't help you. You still need to have the tire fully grounded to the asphalt, and as long as you can endure that and your aerodynamic is still working, you be quicker with the softer suspension if your driver is still confident. That is taking you to the question how your driver preferences are affecting that.
Yeah, and we'll dive into that in just a moment. Before we do so, I just mentioned running onto the bump stops. You've mentioned the term packers as well, and this has come up previously in earlier episodes of the podcast as well. We get this tricky situation with some of these ultra high downforce cars that are now being used in the likes of World Time Attack or Time Attack in general, and these cars are producing, you know, huge amounts of downforce. So this kind of creates a tricky situation for those dealing with the suspension in terms of balancing low speed mechanical grip versus keeping the car off the racetrack at very high speeds without downforces is pushing the car so hard into the track. So, you know, one compromise here is to run what would be considered ultra stiff suspension springs to control that high speed sort of compression, keep it off the racetrack. But the downside of that is the low speed compliance is basically out the door, and it's going to perform worse at lower speeds where the downforce isn't there. The other option is maybe a compromise in terms of spring rate, and then purposely allowing the car to run down onto the bump stops and essentially tuning the bump stop and using packers so that keeps the car off the track at high speed. Can you add anything to that discussion from your own perspective?
Yeah, definitely. We have seen that development also here in GT3 race cars over the last years, that the cars got more and more performance on downforce, and you're with a conventional damper system, which is not solid piston, you have to add more and more spring for sure. You need to have a damper system which is simply reacting quicker. Yeah, and if you work on a hydraulic surface, which is quite big, like a 40 or 35 millimeter piston, instead of only having a 18 millimeter piston rod, then for sure your damping is reacting a lot quicker. You can raise the spring, but the spring height always needs to fit to your downforce. You will never run a high downforce car with a real soft spring, but you can push that point away over a more quality suspension kit, basically.
Again, you mentioned earlier about a third member or heave spring, heave damper arrangement. I mean, this is getting pretty down in the weeds. It's not something we're going to find necessarily on a sort of a sports car, but something we do see consistently on open wheel, wings and slicks cars. So can you give us a high level view of what that third member actually is and how that operates, how it works?
Yeah, basically you can find a good picture on the internet. Right now, the Porsche 963, the actual LMDH car from Porsche, you find a good picture of the rear suspension package. You see the exhaust pipe, you see a huge third element in the middle. Sadly, that suspension kit is made by Multimatic, but they have built the whole car, so it's only logical. But you see basically a third element, and you see a corner damper, and roughly, like you said, there is no black and white answer. Roughly, the roll motion is taken by the corner element. So all the time when the car is pure rolling, the rolling movement is made by the corner dampers, and the whole heave movement, like the car is going straight down under top speed, the whole heave arrangement is ending up in that third element in the middle. So in that kind of race car category, you don't think so much into the four corners anymore. You only think about what kind of motion is the car doing. Is it pitching, rolling, cornering? You don't look so much on the single event anymore. That's the reason why you separate those movements from each other and build a suspension kit for it, basically.
All right. First of all, I just want to apologize because I incorrectly used the term third member. It's still early here, so third element. Thanks for clearing that up. So in essence as well, for these high downforce cars, using the third element, while it adds some complexity, from, again, just reading between the lines here, what it's allowing you to do is sort of consider the high-speed aerodynamic operating region independently from cornering, braking, accelerating. So if I'm right in this, you sort of allows you to utilize what would be a more conventional, slightly softer spring for the individual dampers while still maintaining, keeping the car essentially off the bump stops at higher speed. Is that sort of approximately correct?
Yeah, because basically on the heave motion, you can always see that when the car is in Le Mans running down the Unadier straight, which is still a normal French road, you see straight the car jumping up and down, and you have all the aero forces in the car, and the whole heave forces by moving up and down are pretty massive. So you need to damp the heave movement. The roll movement is not that big. You just damping, basically later on it's all a mixture. But theoretically, you are damping a roll movement and you don't need that high forces. And on the heave movement, you need a bigger hydraulic area to keep that under control. And coming back to the 963 rear axle picture, you see that the heave element is pretty big and the roll elements are pretty small. Roughly, I would say you need twice the forces or twice and a half the forces on the heave elements than on the roll elements.
Right, just while you've been talking, I did just actually search up that photo, so we'll put a link to that in the show notes as well, so that people can easily find that and get a better sense for what we've been talking about. I just wanted to take a moment out of our interview here, and if you're enjoying the interview, then I've got the perfect course for you. That is our suspension tuning and optimization course, and it really dives into a lot of the topics that Thomas and I have been talking about during this interview. I said in the introduction to this podcast that two of the most common questions we get is, how do I choose the correct spring rate for my application, and how do I adjust my bump and rebound settings on my damper? And this course, among other things, goes into detail answering those particular questions. For a start, we talk about the suspension fundamentals. What is the suspension there for, and how does it work? You'll learn about aspects such as sprung and unsprung mass and travel and motion ratios, topics that a lot of people really don't understand. You'll then learn about springs, anti-roll bars, and bump stops and their interaction. The damper itself is actually a really complex topic, and we've got a section that covers covers that in a lot more detail, so you actually understand how a damper works and how the bump and rebound dampening works, or settings work. You'll also learn about lateral load transfer basics. I know that's a bit of a mouthful, but essentially how the load is transferred around the car as we negotiate a racetrack. There's a bunch of practical skills in here as well that are going to be critical for you being able to apply all of the knowledge you'll learn from this course on your own car, such as measuring and calculating center of gravity, motion ratios, anti-roll bar stiffness. You'll learn about how to choose the springs and how to calculate that for your application, choosing and tuning anti-roll bars and your dampers, just to name a few topics there. This course really is perfect for anyone who wants to optimize the suspension and understand the suspension better in their car, and you can get 50% off using the coupon code ThomasKW50, ThomasKW50, and as usual we'll put a link to that coupon code as well as the course in the show notes. Let's get back to our interview now. All right, just coming back to the development of a new product for a motorsport application, and one of the technologies I'm interested in diving into, because I know nothing about it, is a shaker rig. And from what I understand, KW have, I believe it's a 7-post shaker rig at your facility. What on earth is a shaker rig, and how is that useful for developing these products?
Okay, a shaker rig had its first appearance in Formula One, I think in the 80s, because Formula One engineers back in the days wanted to have a look on different suspension setups isolated from track testing. Basically, you put the car on 4 hydraulic actuators with all wheels, and you can just put forces into the car, whatever shape you are interested in, basically. 7-post rig is already adding 3 hydraulic elements. The first element is pulling the car down. All those 3 elements are attached to the body of the car. The front element is pulling the car down, and the 2 rear elements can pull the car also down and can roll the car.
Right, so you can essentially replicate the car's suspension and platform movement as it goes around a racetrack, or a road for that matter, I guess.
Exactly. You can run fully synthetic signals like a heave sweep in 4-post testing, and you can run a racetrack and redrive different parts of the track and just make your assumptions what's better or not.
Okay. Again, as I understand it, not being involved with this technology in the slightest, this has become a lot more prominent maybe in the last couple of decades, just with the drive to reduce actual on-track testing for just about any professional motorsport. NASCAR, IndyCar, F1, basically the list goes on. There's a real drive to limit track testing because it's expensive. So is that one of the things that's driven the use of a rig like this to validate changes in suspension systems?
Yes, exactly right. I would assume that from roughly 2000 to 2020, that tool was helping quite a lot to understand what's going on the racetrack. Due to the COVID pandemic, we found out that we can develop race cars completely at home at the computer. So we simulate a lot more. We have a lot of manufacturers which are only simulating and verifying that on the rig, and you just go to the racetrack and drive it, and you know that it's better. So the shaker rig now is in the middle phase of the development because all the teams and manufacturers want to operate on the racetrack, like with the tire pressures we were talking on. The calculation and the whole performance development has been made by simulation and verified on the shaker rig. I think that is what's going on now.
Okay. In terms of using the shaker rig for validation, I guess really everything comes down to improving that contact patch between the tyre and the track, which in this case, the tyre contact patch and the posts of the shaker rig that it's sitting upon. So what are you using on that shaker rig to actually validate the outputs? Are you physically measuring the tyre contact patch on the top of the post, or is it more around sensors such as damper pots that are fitted to the car and analysing that data after it's been on the rig?
We use all 3 kind of that. We use the linear potentiometers to measure the travel on the wheel or on the damper directly is depending to the customers. We are measuring the forces on the hydraulic actuators directly, and we use also acceleration sensors within the car and on the wheel as well, and derive a certain calculation model from it, which is telling us, okay, you have your contact patch load variation, you have your minimum value of contact patch, you have your pitch sensitivity, then a roll sweep where you can see, okay, the pitch you can also measure in 90 degrees, which is telling you, okay, your car has a roll pitch, how is that looking like, and your aerodynamic behavior in general. Yeah.
Again, these are incredibly complex systems with a lot of complex interactions, so difficult to sort of isolate just one element of a race car. I mean, just listening to you explain that shaker rig, on face value, it'd seem like if you've simulated a particular racetrack on the rig, it'd be the perfect place to not only develop the damper and spring, but also to dial in your bump and rebound settings, which I want to talk in a bit more detail next. So am I right? Can you basically roll off the shaker rig, go to the track and have this mythical perfect setup for that particular track, or is it still not that easy? Is there still some on-track kind of development that needs to be done?
You definitely can have that moment that you roll off the shaker rig, go to the racetrack, and definitely see, okay, you have found something. It depends on our people which are working on the shaker rig. It depends on the people within the manufacturer and how they work together. After a certain while being on the racetrack, you always find a point where you can still be better. But that is definitely possible, but I think the effort to do it is still pretty huge, but not that huge that you would rent the Nordschleife for 3 days and spend 70,000 euros every day. I mean, they are still doing it, but for sure they've been on the shaker rig before and just coming closer to the solution.
So again, it sounds like it's almost a repeat of the discussion about the natural frequency and finding the spring rate. That shaker rig will get you in an operating window, so you're already much, much closer to perfection when you roll off the transporter at the start of a test session. But beyond that, there is still some fine-tuning to go to really optimize the car to suit the driver and the application, the track.
Yeah, definitely. I mean, if you only look on the contact patch load, then you will start pretty soon to be naive and just taking the spring rate down, because a lower spring rate is always telling you a better contact patch load variation. So you could easily lie to yourself. So then on, you also have to have a look on your frequency and your body movements if you are still healthy on that. But if you're taking all that parameters into the right account, and always often don't look only on your calculated model, but also look into your pure travel. If you're already completely in the bump stop, even on the post rig, then you cannot be so wrong. Our development leader on the development department is always saying the post rig is never lying. You just have interpreted the results wrong.
Let's segue into a bit more of a detailed discussion on bump and rebound settings or adjustability in the damping, because this is probably the question that gets asked just as often as what spring rate should I run. It's not uncommon these days for aftermarket sort of enthusiast level suspension kits to have adjustable damping, and that might be a single adjustment. It could be two-way for bump and rebound independently. Some of the more advanced dampers, and probably more along the lines of motorsport specific, are either four-way with high speed and low speed independent bump and rebound, or even five-way with an adjustable blow-off valve for running curbs as well. Can you give us any advice or guidance on how someone is best to make adjustments to these? Is it a case of feel? Is it a case of a test process you go through? Is it a case of needing shock potentiometers, damper travel potentiometers, and analyzing that data? Or is it a combination of all of the above?
First of all, it's always For most of the customers, it's still a luxury situation to have wheel potentiometers. But often, if you set up a car all new, whether it's a manufacturer car or you build it into your garage, a good thing is always to start with the dampers being relatively wide open and just seeing the movement of the car, to also have a look if it's pitching or if it's diving on the front axle more as it's raising on the rear, or the other way around. First of all, you need to see the motions to understand what's going on with the car, and then starting to close it until you come to a point where it's not comfortable or not grippy anymore. And always keep in mind that the low speed, you drive a lot more often to the low speed than through the high speed.
All right, let's just elaborate on everything you've just said there. So essentially, wide open versus closing it down. What you're essentially saying here is start with your bump and rebound adjustments in their softer setting and get a sense for what the car's doing, how it's performing, how it feels, and then start stiffening up bump and rebound until you get to a point where, as you've mentioned here, the car is no longer comfortable. Maybe it's starting to skip over bumps. Basically, there's insufficient compliance in the suspension to maintain that contact patch. Is that about what you're saying there?
Yeah, basically yes. I've been also to development tests with brand new race cars when we were starting with rebound and compression fully open and even disconnected anti-roll bars, to firstly understand what the suspension, the pure suspension of the car is doing. Is it rolling symmetrically from its geometry? Is it pitching symmetrically? And then focusing on the geometry of the car and then going into anti-roll bars and damping. I'm still thinking that that is the way to go if you don't know it better.
Okay. Now, the other term you've used there is, well, we've used it a couple of times now, is high speed versus low speed. And again, we've covered this on the podcast, but for those who are fresh, we're not talking about how fast the car's going. We're talking about the movement or speed of movement of the damper. So can you give us an idea of what is considered low speed travel versus high speed travel, and how does that sort of, how do we get those effects? Is it in terms of transitioning bumps on the racetrack versus driver input? Can you elaborate on all of those elements?
Yeah, for sure. I mean, let's say the body movements by pitching or rolling a speed of 0 millimeters per second to 150 millimeters per second, something like this. It also can be 100 or 200. That is basically the point where you change from low speed to high speed, both rebound and compression. So basically, you run a lot more often in low speed, but the single events which you see in high speed, let's say, can always put you into a situation where you say, okay, I need to drive the stiffer spring because I'm touching the ground there or something like that. So the car is becoming vertically way too quick. And then you have to drive around the stiffer spring over the whole track. So it's connected. We see that always on the Nordschleife when people are developing a new car and they say, high speed is not so important. But yes, you have 5 events where high speed is basically telling you which spring you need to drive because you get in critical situation in Fuchsröhre or Pflanzgarten or how that situations are. You need to work on your high speed to have the softer spring. And with the softer spring, you control your low speed. That's often how the situation is.
Okay. Yeah, so there's quite a complex interaction there between these elements, high speed and low speed versus your spring rate. So if I'm decoding what you just mentioned there, the natural tendency would be to run a higher spring rate to control these sort of high speed inputs that are a few times per lap, perhaps, keep the car controlled and stop it from bottoming. Then you're essentially compromised because you've got this higher spring rate, which is less ideal for some of probably the rest of the racetrack. Am I picking this up right, that an alternative option there is to run a more sensible spring rate, a lower spring rate, and dial in more high-speed bump damping to control the platform and stop that bottoming?
Yeah, exactly. I mean, for example, the 24 hours of Nurburgring, I think it's down there also a pretty famous race. Like 10 years ago, the GT3 cars were landing. Let's say there is a part of the track called Pflanzgarten where the cars are fully in the air. GT3 cars you don't have fully in the air so often all over the world.
Yeah, you'd like to think that would be a rare occurrence. Yeah.
Yeah, exactly. And the cars were landing there 10 years ago with 1.5 meters per second. So a real speed within the damping systems. And nowadays, the car became 20 seconds quicker and are landing with 0.7 or 0.6 meters per second. So you have also found quite some power in your high speed, which is preventing the car from bottoming, and you can focus fully with your spring on the performance relevant situations.
Sure. Now, in terms of that low speed damping as well, this, again, as I understand it, is a lot more related to the feel of the car to the driver. It's about how the car will pitch forward when the driver initially hits the brakes, how the car will begin to roll, or the rate of roll as the driver turns into a corner. So is this an element of the damping that really needs to be tuned to suit the driver's preference in terms of how responsive the car feels?
Yes and no. I think there is an optimum point where low speed is on an optimum level to find all the grip and to still have a platform in the car. But you cannot run a race car if two drivers from 3 or 4 driving that car are telling you constantly on the radio that the car is too bad on platform and you need to change that. For sure, the last thing in that whole row is the confidence of the driver. And that doesn't matter if we are talking about club sport or Formula One.
I can imagine that becomes more tricky as well when you've got a pro-am pairing where you've got a professional driver that maybe is very comfortable with the car moving around, being quite twitchy and difficult to control, which for a professional driver often results in a faster lap time. But you put a gentleman driver or am driver into that car, they don't have the confidence maybe, so it's a case there of detuning the car so that the am driver is comfortable. And maybe that's a compromise for the pro driver. Is that something that is always sort of a balancing act?
Yeah, for sure. Former Formula One engineer just told me, for sure, the Formula One car is always too harsh to drive to the bakery, because that's pretty natural. I mean, if you have an amateur driver is driving slower and also hitting the bumps a lot slower, so for him the impression of the car is always it's too harsh, and the pro driver is a lot quicker and is able to handle that. I mean, that conflict became smaller and smaller in the last years as the cars became better and better.
Yeah. I think like even if we look at the upper echelons of motorsport, and I'm talking here F1, you see that same difference in the design philosophy of a car. And I mean, obviously this is a wider envelope than just suspension. It's aerodynamics, it's everything about the car. But I mean, if you look at Red Bull just as one example, they've developed a car very squarely around their number one driver, which is Max Verstappen, who, at least as I understand it, likes a car that is very, very pointy in terms of the front end grip is immense at the expense of rear end grip, and he can drive that car, whereas traditionally Chico's doing a pretty good job, let's be honest, but traditionally the number two driver at Red Bull has seemingly struggled with the car being designed and developed around Verstappen's style, and that's just one element of trying to get this balance here, that even at those upper echelons there are significant driving style differences and preferences that the driver will have. Coming back to our example here, now we've talked about using feel as an element of dialing in these damping adjustments. You mentioned that shock travel potentiometers are often a luxury, but obviously they do exist. If you do have the luxury of those elements, and for those who aren't aware of what I'm talking about here, it's simply a data analysis tool that provides to your logging system a high-speed interpretation of the damper position and how that's moving. From the damper position over time, the velocity of the damper can then be calculated, and then ultimately we can have a nice shock travel histogram presented by our data analysis package. So the shock travel histogram sort of of shows us the percentage of time that the damper is in high speed and low speed bump and rebound. And essentially we kind of get something that looks hopefully a little bit like a standard distribution curve. Okay, so a question here after we've got that sort of preamble out of the way. If you've got the data to look at in terms of shock potentiometers, what are we trying to do? How can we interpret that data? How can we utilize that data to help us with our damping adjustments? And just as importantly, if we have that data, can we discount completely driver feedback, or does driver feedback and the data kind of get interpreted hand in hand?
First of all, I need to say the interpretation is going to happen hand in hand. You cannot negotiate completely what the driver is saying over the data, even if that is always the big dream and became kind of reality in the last years. I mean, the first thing I would look on within suspension potentiometers is I would look into the transient data, into the pure measurement. How often am I on that racetrack in the rebound stop, and how often I am in the bump stop, and what is my distribution effectively between bump and rebound. I always would build channels where I would say, okay, I check my distribution front to rear and left to right. And if that is healthy, then I can look into histograms. But the histogram is often, in my opinion, coming later on in connection with force data and things like that on the racetrack. The transient look on the data is really, really important. That's what I think.
Okay. So if we've got our bump and our rebound damping sort of separated out, do you use that transient data and then the histogram data there to try and equalize so that the suspension is essentially spending the same amount of time, 50% of its time in bump and rebound travel? Is that kind of the target, or does it get a little bit more complex than that? Am I trying to make things too simple here?
Yeah, exactly. I mean, that's kind of the target, but you always are interacting with a wheelhouse, which is allowing you a certain compression travel and a certain rebound travel. A good example is two car categories which are kind of close together already, GT3 and GT4. And the rules say that GT4 still has to use the geometry of the street car. You cannot make the car wider. So all the GT4 cars are pretty limited on compression travel and still working a lot on rebound travel. On the GT3 cars, you have the full prototype wheelhouse, basically, when there is a steel body on the inside, but still you have a lot of prototype shape there. So you're working a lot more on compression travel and only a little bit on rebound travel. So basically that distribution is given by the car itself. You just need to make sure that you still find all the grip. And if you erase all the rebound travel on the GT3 car, you won't find the grip. And if you erase all the compression travel on the GT4 car because you're driving it way too low, you will also lose grip.
Okay. Yeah. Again, just to sort of reiterate that these are complex interactions. It's not something we can sort of make black and white rules for, but hopefully people listening to this will start to get a bit of a better understanding of how all of these elements work together. We did mention earlier about the term roll center height. And I mean, really, this kind of probably gets us a little way outside of the level of professional motorsport, but I'm probably aware that most people listening to this will be at the enthusiast level, maybe modifying a road car for track days, or maybe they've got a dedicated race car, but chances are it's probably not the latest and greatest GT3 from Porsche or Ferrari. So let's come back to something a bit simpler. And I mean, in road car applications, I mean, this happens in McPherson strut, multi-link, double wishbone. It doesn't really matter, but let's just take McPherson strut for an example here. When we lower the car, because obviously we've grown up our whole lives seeing race cars and how incredibly low they sit on the racetrack, a lower ride height obviously reduces our center of gravity height. So clearly, this is a good thing for handling. And on face value, yes, but there's a few more elements with this. So when we lower the car, we affect the roll center height, which is an imaginary point in space based on the geometry of our suspension that the car will roll about. And when we lower the car, we lower that roll center height. And it's really the difference between how much the center of gravity lowers and how much that roll center height lowers that will define whether this has been a good thing or a bad thing. So with that kind of introduction to the topic out of the way, can you talk us through the downsides of lowering a car when that roll center gets too low?
Yeah, like I mentioned, we have on the Nurburgring class, which is basically standard class, just with a roll cage in it. On the McPherson axle, by lowering the car by 1 millimeter, your roll center is shrinking down by 2.7, something like this millimeters. So if you lower the car by 20 millimeters, you have like 50, 60 plus millimeters, depending on your axle, where your roll center is going down. So even if your center of gravity is lower, your lever arm between an imaginary rolling axle and the center of gravity became bigger. So effectively, you also have a good chance of even rolling more than before. Plus, your multi-link axle on the rear, for example, the roll center doesn't shrink so much down like on the McPherson axle. So basically, you have a roll axle in the car where your car starts to roll completely unsymmetrical. On the rear, it's probably still healthy. And on the front, it's a mixture of diving down and rolling, which is not healthy to have the tire in the complete contact patch load window.
Yeah, so a couple of elements I just want to expand on a bit there. And the first is it's a concept that is a little tricky to get your head around without the benefit of images. And maybe we can chuck a couple in the show notes as well, just to help people really sense this. But that when we lower that roll center height and it lowers more than we lower the center of gravity, as you mentioned there, it creates essentially a lever arm, and the car is going to roll around the roll center. We've got a greater distance between the roll center and the center of gravity. So as you lower the car, potentially the car is actually going to body roll more, which would be counterintuitive to what most people think. Again, this sort of comes back to that assumption that lower is better. The other element, which is probably even less obvious, is when the front and rear roll centers lower at a differential rate. And if we look at the roll center height front to rear, and we look at the car on a side view, and we draw a line through those, there's an axis that the car is going to roll about. And by adjusting the roll center height front to rear, this also impacts the handling balance of the car between understeer, neutral, and oversteer. So what seems to be a subtle element, just lowering the car maybe 20 millimeters, that actually can have a massive knock-on effect to the overall performance of the car, often for the worse, as well as the handling balance. So what are the solutions in terms of fixing this problem if we want to run with a lower ride height?
If you are not able at all to change your geometry somehow, then for sure you need to run. You have two options. For the non-transient behavior through cornering, you need to stiffen up your anti-roll bar to prevent that car from that pure rolling, or to stiffen up the spring. Plus, for sure, you need to run a more quality damper, which is able to handle that bigger stiffnesses which are in the body right now.
Sure. Another element I just want to chuck in here into the mix as well, because again, it's something that if you're not aware of it is easy to overlook, and that is the camber curve of the suspension. So less of an issue with double wishbone, because one of the benefits of double wishbone and why it's kind of the go-to for professional race cars is that there's a huge amount of flexibility that the design engineers have in terms of engineering a camber curve into it to do whatever they want. And when I'm using that term camber curve, what I'm meaning is if we look at our static camber at ride height and then we compress the suspension, what's actually happening to that camber? And ideally what we really want to do is gain negative camber as we compress the suspension, so that we don't need to run so much static camber, which affects our acceleration and our braking. So if we look at what happens with a McPherson strut, the situation is a little less ideal than double wishbone, in terms of if we lower the car too much, we're already at a point where as we compress the suspension further, we actually lose negative camber. Is that correct?
Yes, depending on the suspension itself, but for sure, if the car is rolling more, or the body is rolling more, you're also dissolving that camber gain and the static camber that you have. So probably you find yourself in a situation where you're only leaning on the outside of your tire, and then that doesn't help you at all.
Yeah. I mean, ultimately, if you're stuck with factory geometry and it's a McPherson Strut car, there are just some compromises. And that's not necessarily a bad thing. It's, again, just understanding the compromises you are going to be making and also understanding the knock-on implications of the decisions that you make in terms of, will we lower the car? How much are we lowering the car? What's that going to do to our roll center height? Are we able to correct that? What's that also going to do to our camber curve? And then what that may require in terms of our spring rate. So again, it just comes down to, there's no black and white here, as there is a lot of gray areas, and just understanding the system in its entirety.
Definitely. I mean, as a club race driver, or if you're building the car in your garage, you still can always help yourself if you pull out the spring, doesn't matter what kind of suspension you have, and drive through the whole travel and measure like your wheel alignment through the whole travel and measure your toe and camber curves just to come closer to the solutions. That's what we always say. Take out the spring and spend time with your suspension setup, go through the travel and look what the suspension actually geometry wise it's doing. And you also will find out if your wheel is touching the wheelhouse inside, or if your wishbones are probably not even able to deal with all the travel what your piston rod is able to do.
Yeah, I think there's a lot to be said for that, and it doesn't really cost anything. It's just some time. And if you spend that time, the revelations that you can come up with often are quite amazing. A common one, I've seen this a couple of times just in the last year, a race car that's been set up, that's been aligned, it's been running, and maybe it's got a bit of a handling imbalance, maybe it's suffering from some high-speed understeer, and just going through that process, and as I say, I've seen this firsthand in two separate race cars, and you sort of find that when you actually analyse the suspension travel, that once it's beyond about 20 millimetres of compression in the front suspension, it's sitting hard on the bump stop. And on face value, you wouldn't know that. So therefore, modifying the bump stop or raising the suspension and giving some more compression travel instantly changes the whole handling balance of the car. So these little things, again, free, just takes a little bit of time and an understanding of what you're actually looking for. One last topic I really wanted to cover with you, Thomas, is adjusting ride height on a coilover suspension system, because this is an area where I see so many people doing this, what I consider at least to be wrong. Hopefully you're not going to make a fool of me here and disagree with me. And also I see this as kind of come full circle, because a lot of the enthusiast level coilover manufacturers actually recommend doing it what I consider to be the wrong way. And what I'm talking about here is generally with a modern coilover, and again, just for simplicity, let's say it's McPherson Strut, but same could go for a double wishbone or multi-link. You're going to have a damper that has two separate adjustments. One will be where the lower mount for the McPherson Strut for the hub screws onto the body of the damper. And then, of course, we've got the spring platforms, which we can adjust. So there's two ways we can adjust the ride height. One would be to, and this is quite commonly explained, we adjust the spring platform until the spring is just barely captive, and we lock that up and we never consider it again. And then we adjust our ride height using that lower mount. That would be what I'd consider to be the incorrect way of doing it. The flip side of that is how I go about it, and how we explain this in our suspension course would be to take the spring out for a start, and basically adjust the lower mount first of all, so that we are preventing any potential for wheel to bodywork contact at full compression. We can get a really good sense of where the damper is going to be sitting at full bump travel, where it's going to be sitting and contacting the bump stop. And that also allows us then to set the relationship between bump and rebound travel from our desired ride height. So once we've got that locked up, we don't need to adjust it unless we're targeting a ride height change. Then we use the actual spring platform to set the ride height. And I think where this becomes scary is that people think that when we inevitably end up needing to preload that spring, we're not just in a situation now where it's barely captive. We might need to compress it 25, 50 millimeters to get our desired ride height. people then naturally think that this is going to have a negative impact on the compliance of the suspension. I hear people saying that it's changing the spring rate, which for a linear rate spring is absolute nonsense. First of all, am I on the right angle with this technique? Is this the one that you would personally recommend as well?
Yeah, definitely. You said it fully right. If you have a spring with a certain spring rate, that's basically your spring rate for the corner. Before you're blocking the spring, then your spring rate for sure goes up. But as long as you're driving in a linear range of the spring, then that's your spring rate. And the changement between the housing of the damper within the upright plus changing the spring platform, it's only changing the ratio between bump and rebound travel effectively and the height of the car. That's what you need to understand, basically.
Just speaking about that relationship of bump and rebound, I mean, it's pretty simple, but what we're talking about here is from ride height, how much travel does the suspension at that corner of the car have available in bump before we hit the bump stop, run out of travel? And conversely, if we lifted the car in the air, maybe it goes over a jump at Nurburgring, how much travel from ride height does it have in extension or rebound travel before it's at its full travel? Have you got a bit of a guide or rule of thumb that you like to use in terms of what that relationship should be? Are we 50-50? Do we want more bump travel than rebound? Does it depend whether we're road racing or rally? Yeah, what's your sort of take on that?
I mean, to say a rough number without aerodynamical influences, I would rather suggest to have 45% compression travel and 55% rebound travel, something like that. On the most modern McPherson suspension system, like you said, you can also adjust how your damper housing is adjusted to the upright and play with that height and just make sure you have the right amount of compression and rebound travel. And that will not change any preload or linearity on your rate and things like that. That is coming on a completely different level.
Sure. Now, I know that a lot of people who are listening to this are probably sort of sitting at home right now thinking, no, Thomas is wrong, Andre's wrong. I'm just going to stick to how BC's tell me to adjust my ride height on the box. And I think this is one of the reasons why this confusion exists, because there are these manufacturers, I've used BC, but they're not the only ones that actually say, give us the wrong information. Now, I also admit that many, many years ago, before I really got a deeper understanding of this, I also set this up incorrectly, and it really got drummed into me with one of our test cars, which is a Toyota 86. We started out, why this became apparent to me was I was going through a process of testing with a variety of different spring rates, and what we actually did was start quite stiff and go softer. So if you use the technique that is recommended by some of these other coilover manufacturers, and I use BC because that was what was in the car, put your new spring in, and you adjust that spring platform till it's just barely captive, put it in the car, and then set the ride height with the lower mount. So that's fine. We start out, let's say, just for round numbers, with a 9 kg spring in the front, and we test the car. Okay, we go softer, we go 7, we go 6, we go 5 kgs. Now, if you go through that progression from stiff to soft and you use BC's recommendations, each time you go softer, in order to get back to your desired ride height, you have to wind the strut body out of the lower mount. So essentially, every time you go softer, what you're actually doing is eliminating a portion of your compression or bump travel. And why this became really apparent to me is at the end of it, the car was handling on these softer springs terribly. And it became pretty easy to notice that the reason it was handling so badly was because I'd reduced or eliminated almost all of the compression travel, and we're essentially sitting on the bump stops with anything more than about 5 to 10 millimeters of suspension movement. So as soon as you go through that process that I went through, sort of a light bulb goes off, and you're like, this is not the way, this is a problem, I'm compromising my suspension travel, and then you start looking at the bigger picture. So I just wanted to give that experience that I went through to those who are maybe on the fence and aren't quite believing what we're talking about here. If you go through that personally, it becomes a no-brainer, and you have to understand that this is the wrong way of doing it. Right, Thomas, let's move towards wrapping this thing up anyway, and we're going to finish off with the same 3 questions we ask all of our guests. And the first of those is, what's next in the future for you and maybe KW?
We are building a suspension kit for Le Mans, and we will enter WEC and IMSA in the next years. And that will definitely be a new story for me and for KW to be above GT3 level.
Yeah, there's a massive movement into sort of the upper echelons of professional motorsport, and no doubt there'll be a huge learning curve and many lessons that maybe then will feed back into your other suspension systems. I'm guessing, is that a fair assumption?
Yeah, definitely. I mean, you take a lot of the learnings from the last years, but you also have to rethink different shapes of low speed compression, how it's looking like, the weight on the damper, how the quality of the system is like. You have to rethink things on a different level.
Yeah, that makes sense. All right, next question. Is there any advice that you give to a younger version of yourself, or maybe one of our listeners, to help reach where you've got to today in your career faster, or potentially avoid maybe some pitfalls that you came across on your travels?
Yeah, probably I would stick to things more, to jobs more, to tasks more in a difficult situation. So basically the old advice, never give up, even if it's sometimes difficult. Stick to it, be open for it, and travel over the globe. I mean, the main racing industry is still in Great Britain or still in the US. Yeah, just be open and just be focused, then it will go in the right direction.
Yeah, I think that's probably a good point about the location of global motorsport, and you're absolutely right. I mean, if you want to be involved in the highest levels of motorsport, like it or not, you are probably going to need to be locating yourself either in Europe or in the US. And for those who really have a desire to make a career out of that, that's something, if you're from outside of those regions, you're going to have to really think seriously about, because being there is going to open up so much more opportunity than if you want to stick to your own country where motorsport might not be so prevalent. Case in point is New Zealand. Our top level of motorsport is pretty limited. There's probably a dozen GT3 cars in the country, certainly not enough for a GT3 championship. So yeah, it's definitely a very different situation here, much more sort of teams working on shoestring budgets, and that in turn limits how far you can progress. All right, last question for today, Thomas. If people want to follow you and see what you're up to, how they're best to do that? You got any social media accounts you'd like us to follow along with?
Yeah, I don't know, I'm still pretty much an old school guy on that one. I'm access to LinkedIn. It's a business network. You can connect there with me. I'm always a busy person. I have family, I have 2 children. I don't want to stick to the cell phone too often. But if you follow me on LinkedIn, then you can see what we are actually doing, on which racetrack we are right now doing service, and get in contact with me. Yeah, definitely.
Perfect. How about KW themselves? How best to get in touch with KW?
KW is basically on all the social media platforms you're common to. Yeah, definitely.
Okay. Well, as usual, we'll put up some links to the accounts in the show notes to make it super easy for our listeners to find them. Look, Thomas, really been great to get some deeper insight into the world of professional motorsport suspension. So really appreciate your time today. Thanks for everything you've been doing there, and all the best for the future.
Perfect. Thanks a lot. I hope it wasn't too boring, because to talk to engineers is always a difficult story, to not be too much into technology. But yeah, that's basically how our work life is,
I think it's probably one of those things, like most of our podcast episodes, it's not going to appeal to everyone, because it is a very niche topic, but that's what we specialize here at HPA. But for those who really are sort of suspension nerds and want to learn more about it, I think it will have been really interesting. So no, we really appreciate your time, and I, for one, found it really interesting, definitely not boring. So thank you again, Thomas.
Perfect. Thanks. Bye-bye.
If you enjoyed this episode of Tune In with Thomas, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. Also, this is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Team Sunshine from Australia, who has said, a great mix of short and long form podcasts on everything from Formula One to cutting edge drag racing. I can't stick it in my ears fast enough. Well, glad you're enjoying the podcast, and thanks for the kind words. If you want to get in touch with your t-shirt size and shipping details, we'll fire a fresh tee off straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.